All right, welcome to a brand new topic, a brand new concept, and we will be looking at what we call oxidation and reduction. This is quite an intense topic in the sense that it is done again in grade 12 in a deeper dimension. So we are laying a foundation for our grade 12. In grade 12, it is called electrochemistry. But for now, we're not going to go into the electrochemistry part. We just want to understand what reduction and oxidation is. That's all for now. Okay. We will be using some tables. Some of you have been seeing that table, but you don't know what it is used for. We are going to see how to run through that table today. Our first thing is to look at what we call oxidation number. All right. So please follow. It's very new to all of you in grade 11. So please follow. Oxidation number. I have to quickly define this and look at the properties of oxidation number. We need to know what oxidation number is. And we're going to look at various examples. We're going to calculate as well. So please get your calculators ready and let us do some real good work. Okay. What is oxidation number? I'm going to quickly define this oxidation number and look at how to calculate oxidation number for certain elements. And then we will look at rules of oxidation number. All right. What is oxidation number? Now, this is the number of electrons. Okay, I'm going to give you the definition now that you can write down. All right, let's say a number assigned. It is a number that is assigned to an element. A number assigned to an element in chemical combination. Number assigned to an element in chemical combination which represents the number of electrons. Now that's the key, which represents the number. Okay, let me allow go in. Which represents the number of electrons that is lost or gained. Please, that's the key. The number of electrons that is lost or gained. All right? By an atom. Of that element, by the atom of the element in a compound. Quite long definition. Just need to understand what it means. For example, if I write X plus, it means X atom has lost one electron. If I write Y2 plus, right? It means Y atom has lost 2 electrons. And in this case, oxidation number equal to +1. Here, oxidation number would be equal to positive 2. I write C negative. Okay, I don't want to use elements. I write, so we said XY. If I use Q negative, it means Q atom has gained 1 electron. The oxidation number is, if I write PQ, let's write, I don't want to use P. Let's say R, 2 minus. Check what I'm writing, not minus 2. 2 minus. It means R atom has gained what? Electrons. Oxidation number, therefore. So basically, take note. The plus tells you we are losing. The negative tells you we are gaining. Plus tells you we are losing, and the negative tells you we are gaining. Plus tells us we are losing. Now we're going to quickly learn the rules of these oxidation numbers and how to assign these oxidation numbers. Rules of oxidation numbers and how to assign. So basically, I've simply explained to you charge on an iron. All right, the charge on an iron would actually tell us about its oxidation number. The charge on an iron would simply tell us about its oxidation number. Now, let's quickly look at some important rules. Rules of oxidation number. About 10 of them that we need to know. Rules of oxidation what? Numbers. Because we are going to calculate, guys. Number one. Rules of oxidation number. Let's start by saying that the convention is that cations are written. Okay, convention. Cations are written before anions. Cations are positive ions. Are written for anions. Anions are negative ions. For example, if I write NaCl, what does that tell us? Positive first is Na plus because it's group 1, Cl negative. I write HCl. That tell us H plus and Cl minus. Positives first and negatives. Which means if I have something that looks like this, NaH, it therefore means the Na will be plus, and this time around, H will be negative. Convention that we write the cations before the anions. Sit here. And the cations are positive, anions are negative. Anions are positive and cations are negative. Number two, oxidation number of a free element, very key. Example, if I just write sodium, oxidation number, write ox on, ox number will be 0. If I just write sodium, if I just write zinc, Zn, the oxidation number it's a free element. It's not connected to anything. Right? Oxidation number is 0. Element, or we call it the free state element. But 3 now. But 3. The oxidation number of a monoatomic. Monoatomic means 1. The oxidation number of a monoatomic. Remember, mono means what? 1. Monoatomic ion is the charge on the ion. Oh, which is what I was trying to explain earlier. It's the charge on the ion. The oxidation number of a monoatomic ion is the charge on the ion. For example, if I tell you that Na plus, what is the oxidation number? Positive 1. I tell you Cl minus, what's the oxidation number? Negative 1. If I tell you Al3 plus, what's the oxidation number? Ox number, positive 3. If I tell you O2 minus, what's the oxidation number? Negative 2. Are you seeing that, right? Okay, so that's how it works. If I write N3 minus, nitrogen, oxidation number, therefore, is negative 3. So the oxidation number is simply the charge on the ion. If it's a monoatomic means 1 ion. Now we're going to look at specific elements now. Number 3. At specific elements. We're going to look at just 2. We're going to look at hydrogen and oxygen. The oxidation number of hydrogen is positive 1. Number 4. 4. The oxidation number of hydrogen, positive 1. Except, now we have exceptions. Oxidation number of hydrogen is positive 1. But we have a few exceptions. We have a few exceptions. And I'm going to give you those list where we have the exceptions. Just 1 second. Then I will be using oxidation number to show you some certain reactions. All right. Oxidation number of hydrogen is positive 1. Okay, sweet. In most compounds. Okay. Except compounds, let me add this. Except compounds where except compounds containing less compounds that have less electronegativity, except compounds that have less electronegativity, that have less electronegativity than hydrogen. We did electronegativity in grade 10. For example, check this. In lithium iodide, right? NaH, lithium hydride, sorry, sodium hydride, and calcium hydride. Oxidation number of hydrogen, oxidation number of hydrogen is -1. I'll show you how we get that oxidation number as -1. Oxidation number of hydrogen is -1. Right? Number 5. Let me run through quickly before I start doing calculations. Number 5. The oxidation number of oxygen. Oxidation number of oxygen, -2 in most compound, except in peroxides. Peroxides, such as hydrogen peroxide, H2. In this case, the oxidation number oxygen is -1. I'm going to do all my calculations at the same time. Number 6. Number 6. Halogens, 7, right, have oxidation number of -1. Halogens have oxidation number of -1. 7. 7. Neutral compounds. Neutral compounds have a sum of oxidation number of 0. Okay, neutral compounds have, let me just say, an oxidation number, a net oxidation number of 0. Example, if I write a compound like sodium chloride, the total oxidation number is 0. Finally, number 8. The oxidation number of a compound ion the charge on the ion. For example, SO4, 2 minus. When I say compound, it's an ion. Why is it an ion? There's a charge on it. The oxidation number here is equal to -2. If I write Cr2O7 minus, 1 second, let me check something here quickly. Cr2O7 2 minus. Oxidation number of the compound is -2. So take note. It is the charge on the ion. We're going to do some calculations now. These are basic rules that we need, important rules that we need. Thank you, Mr. Petrus, watching online, watching on our live streaming YouTube. Thank you, Science Vibers with Mr. Michel. Even OF2, oxidation number of oxygen, is +2. Beautiful. Lovely. Thank you for those comments. This is very, very important that we get these oxidation number rules. Let's look at a few examples. I want to look at a few examples in terms of calculation. Then we will define. We will then define. Examiners will tell us to calculate. All right, let's check this. Examples. Examples. Calculate the oxidation number of, okay, number one. Let's see. Let me do this. Calculate the oxidation number of each element. I think I will do this. Of each element or each ion. Let's use the word element for now. In A, number one. K2Cr2O7. Want to look at the oxidation number of all of this. Let's break this down, guys. The first thing I'm going to look at is, look, it's a neutral compound. There's no number at the top there. So it means the net oxidation number by 8 or so would be equal to what? 0. Now, I'm going to use my periodic table now to do a few things. K2Cr2O7. All right, K is potassium. Where is potassium? Potassium is in group number 1. It therefore means, I should have added that, the oxidation number of potassium is +1. In fact, let's quickly add that. Let's add that before we start looking at this. Number 9, oxidation number per group. For group 1, group 2, group 3. Oxidation number is +1, +2. Now, when we get to group 4, what happens? Group 4 undergoes covalent bonding because it's in the middle. Therefore, we can go to group 5 because group 4, they are not losing and they are not gaining. If you remember our definition, we spoke about number of electrons lost or gained. Now, if I'm in group 5, my oxidation number becomes -3. I am gaining 3 electrons. Group 6, -2. I am gaining 2 electrons. Group 7, -1. So here is the loss of electron. This one talks about the gain. Once we gain electron, it becomes negative. Lose electron, it becomes positive, simply because we have more protons then. So here we're saying we have number of protons, therefore be greater than number of what? Electrons. For this one, because we are gaining electrons, that's why it's negative. Number of electrons is greater than the number of what? Protons. hence the negative sign. O2 minus tells me oxygen atom has gained 2 electrons. So working with our periodic table, we can actually predict some of this oxygen. Now let's come back here. I hope you're done. Let me wait a few seconds. All right, let's run quickly now. If we now look at this K2, I have a periodic table here. Where is K? Potassium. Potassium is right here, group 1, which tells me oxidation number is +1. All right, now watch the maths, everybody. It is +1, but we have 2 atoms there. So it becomes what? +1 multiplied by what? 2. Plus, okay, we don't know chromium, for example. Chromium, but it's 2Cr. Is that okay? Plus oxygen. The rule says the oxidation number of oxygen is what? -2, except in peroxides. It means I'm going to be dealing with -2, but multiplied by what? 7. And everything should be equal to what? 0. Oxygen is in group 6. So oxidation number is what? -2. Standard, except in peroxides. Oh, let's do the maths now. 1 times 2 would give us 2. R minus 14 equals to 0. 2Cr equals to what? 12, +12. Chromium, therefore, is +6. Let's quickly write that. Because the net must be equal to 0. I'm going to try to give us a few questions now. And we'll look at some special cases. Some very, very special cases. All right, let's do this. Determine the oxidation number let me give you a compound of sulfur in 1, A2SO4, and number 2, H2SO3. I'm only focusing on sulfur now. I mean the oxidation number of sulfur in NaSO4, sodium sulfate, and H2SO3. We are thinking H2SO4, but no, this is HSO3. I'll give you 3 minutes to just give me a trial, and we'll take it from here. A neutral compound, so it should be 0. 40 seconds left. All right, let us mark quickly without wasting time. Number one, sodium is in group 1. So it's going to be positive 1 times 2. We don't know 4. Oxygen is negative 2 multiplied by 4. Because it's neutral, it's 0. So 2 plus S minus 8 equals to 0. Positives, please make sure it's not 6, it has to be positive. The number is very important. Okay, number 2, hydrogen is positive 1 multiplied by what? 2 plus sulfur. Oxygen is negative 2 multiplied by 3. Again, neutral atom gives us 0. 2 plus S minus 6. S is positive 4. Plus acid. I hope it makes sense. Right. Now, let's look at some other ones. If I want to calculate the oxidation number, of sulfur again in number 1. Right, look at this one. Look at this. Look at this one. It's going to be very, very different. Very, very different. This time around, this is a compound ion. Thank you, Taiba. Beautiful answers. Lovely. This is a compound ion. So the net oxidation number is equal to negative 1. Now, hydrogen will still be positive 1. Sulfur plus oxygen is negative 2, but there are 4 of them. This time around, it's not equal to what? 0. It is equal to negative 1. Compound ion, point number 8. So what do we have? 1 plus S minus 8 equals to negative 1. 1 minus 8 is what? Negative 7. If we move that negative 7 over to that side, it becomes what? Positive. 7 minus 1 then gives us what? Positive what? 6. Write that down and then do this. Oxidation number of sulfur in SO4 2 minus. Please share your answers with me once you're done. Are we done? Share those answers with me as quickly as possible. You guys are giving me positive 6. All right. So we have sulfur plus -2 multiplied by 4 to give us -2. Therefore, what do we have? S minus 8 equals to -2. It becomes positive what? 6. We're good. All right. Let's move on quickly and look at a few special cases. Hydrogen peroxide. I want us to focus on these special cases. H2O2, hydrogen peroxide. Hydrogen peroxide. Watch this. They're looking, I want to calculate the oxidation number of oxygen here. Hydrogen is positive 1 divided by 2 plus oxygen, which is 2 oxygen, and that should be equal to 0. Oxygen, not 20. Oxygen, therefore, will be what? -2. Oxidation number of oxygen, therefore, is negative. I said it earlier on that oxygen has an oxidation number of -2, except in peroxides. I don't remember what point number that was. Let's quickly check that point number, and that's what I'm trying to prove now. Number 5. Oxidation number of oxygen is -2, except in peroxide, such as H2O2, hydrogen peroxide, and -1. Please write that. That's a very, very important one. A special case. Not a peroxide, right? This is not a peroxide. So the oxidation number of oxygen must be -2 here. So let's find the oxidation number of chlorine. Hydrogen will be +1. Oxygen will be -2. Check for chlorine, and this must be equal. What is 1 plus 2? 1 minus 2. This is 1 minus 2 plus Cl. This is -1. Now check. Cl therefore becomes what? +1. This is going against what we said, that oxidation number of halogens should be -1. In this case, oxidation number of chlorine is what? +1. I want to give you a reason now. Is that okay? Here, oxygen is more electronegative. Electronegative. That we can check from the table. All right. Then, and therefore, it maintains negative oxidation state. Or electronegative, it maintains its negative oxidation state. That's why it's not changing. So it forces chlorine to change. Chlorine, therefore, must be +1 for us to balance. Chlorine have a +1. Balance the overall, to balance the net what number? But net oxidation number must be equal to what? 0. So I'm looking at exceptional cases here. Hydrogen peroxide, oxidation number of oxygen is -1 as opposed to being -2. I hope we are looking good together. But a few more. What about water? H2O. Happen. One is simple. Hydrogen would maintain its +1, but multiplied by what? 2 plus oxygen. Oxygen will be what? -2. So they're fine. With H2O, hydrogen, oxidation number of hydrogen is +1. Oxygen is -2. Problem there. What about methane, CH4? Methane, CH4. What's going to happen? Hydrogen in this case will be +1 as well. All right. So carbon plus 1, +1 times 4. I'm looking at exceptional cases here. 4 equals to 0, negative. That means here, oxidation number of carbon is -4. Hydrogen is what? +1. Why is this special? We had said earlier on that we write the positive first before the negative. But this time around, can you see something different there? We are looking at special cases here. I have already looked at HOC. Okay, I've already looked at hydrogen peroxide, right? We said hydrogen is +1, oxygen is what? -1. These are special cases that we are now making a list of. What about carbon dioxide in CO? Definitely, oxygen is -2. So carbon plus -2 multiplied by 2 equals to 0. Check. I wanted to see something. That carbon was +4 is +4 in carbon dioxide, but in CH4 it is -4. Just check. These are the special cases that we have. Carbon equals to +4, oxygen is equal to -2. Take note of special. I think we also did HOCl. That we did, right? Hydrogen, we said, is +1. Oxygen is -2. Cl is +1. Different from convention. Conventionally, we know that Cl should be -1. All right. So that is how we calculate oxidation what? Numbers. Let me know if you guys are okay. Just give me a thumbs up. This screen actually shows the special cases. All right. Now, let's go look at two keywords. And this is the crop and this is the peak of the whole lesson. Two keywords: reduction and oxidation. Okay. Or what you can call oxidation and reduction. Oxidation. and redefine this in two ways. In terms of electron transfer, we are going to define in terms of electron transfer, and then we will define in terms of oxidation number. There are two criteria. There are a few more. There are actually about 4, but we are going to limit ourselves to 2. Oxidation is the loss of electron. Reduction is the gain of electron. When an atom loses an electron, when an atom loses an electron, it's called a cation. Atom gains an electron, becomes negatively charged, and it is known as an anion. Important to get those definitions once and for all. Oxidation will be an increase. Oxidation number while reduction in terms of definition a decrease. Oxidation is an increase in oxidation number and reduction is a decrease in oxidation number. Please take note of those definitions. They are very, very key. Now we're going to look at a few examples and try to see how this works. And then we define a type of reaction, and that reaction will be called a redox reaction. So we're going to see different types of reaction. Okay, let me start the next concept by saying a redox reaction. So redox is a combination of the two words, right? A redox reaction, a reaction where oxidation and reduction, oxidation and reduction occurs. And when we say oxidation and reduction occurs, we're talking about what? A change in oxidation number. An ion that does not experience a change in oxidation number called a spectator ion. Called a spectator ion. You see, the oxidation number will not change. Those type of things are called spectator. They're just watching. They are just watching. Okay? Don't forget what our definition is. Let me go back here. Our definition here, we normally use what you call oil rig. Oil rig. Oxidation is loss. Reduction is gain. Oxidation is loss. Reduction is gain. I want to look at two more definitions, then we go into some equations. What is an oxidizing agent? Something that causes another compound to be oxidized, right? So we say this substance, right, that gains electron. Hence, it is reduced. Please take note of the opposite that we're looking at. It is reduced. An oxidizing agent will be reduced. What is a reducing agent? So quickly start thinking. A reducing agent will be oxidized. A reducing agent will be oxidized. But what is oxidation? Oxidation is the loss. So what are we going to say? An agent will be oxidized. So we say this is a substance that loses electrons. Hence, it is oxidized. Please take note of the difference between the two. We are saying an oxidizing agent while a reducing agent, that will guide you in definition. A reducing agent is oxidized. When you get to grade 12, I will be using some formulas to help you do the definitions. An oxidizing agent is reduced. And what is reduction? The gain of electrons. So I'll say an oxidizing agent is a substance that gains electron, because the gain of electron is reduction. Reducing agent is oxidized. I want us to look at a few equations together, and we are going to play around their oxidation numbers, and we're going to balance an equation quickly. So you got to run with me before I even show you how to use the table. All right, are we ready? Table is the last thing I want to show you. I want us to work without the table first. Look at this. Number one, Mg, which is a solid, burns in oxygen, all right, which is a gas, and that gives us magnesium oxide. Okay, let's balance it. We need a 2 there, and we need a 2 there. My issue now is, let us quickly deal with the oxidation numbers. Please follow me on this example very closely. Using our laws of oxidation, what is the oxidation number of Mg? That's point number 2. An element in free state has oxidation number of 0. So oxidation number of Mg is 0. Oxygen as well is in a free state. Is that okay? It's not combining with anything. So the oxidation number also is what? 0. Diatomic, but there's no number on top, so it's 0. Now, in a compound, we now have a compound. What is the oxidation number of oxygen? Oxygen would be what? -2, because it's now in a compound. You see, if it is alone, it is 0. But now it's in a compound, we bring in the oxidation state. What about magnesium? Magnesium will be positive what? 2. Remember, it must give us 0 at the end. Okay, let's look at these numbers. Magnesium moved from 0 to positive 2. What is that? That's an increase. Oxygen moved from 0 to -2. That's a decrease. Therefore, we are going to say that magnesium is oxidized. Please check. Mg is oxidized to Mg2 plus. Guys, because here what we have is Mg2 plus and O2 minus. Magnesium is oxidized on from the left to the right, Mg2 plus. Is that okay? That's how we are going to answer the question. Magnesium is oxidized. No. Someone saying something? Magnesium is oxidized. Why? There is an increase. Why is it oxidized? Because there is an increase in oxidation what? Number from what? From 0 to positive 2. Sense? Therefore, magnesium is a reducing what? Agent. Whatever is oxidized becomes the reduced. Take note. Magnesium was oxidized to Mg2 plus. Why? Magnesium changes oxidation number from 0 to positive 2. I want to look at some intense examples with you. Very intense now. And I'll be showing you a few things here, guys. Please, I need you to come on board with me. Next week, I'll use the table. Today, I want to work without using a table. I want us to work manually and understand chemistry. Once you work manually and understand chemistry, you'll be able to get, you'll be able to understand and appreciate the table. Let's look at a question together quickly. Let's look at this question together. Check this one. Mg again plus zinc chloride give us MgCl2 plus zinc. And please, I'm going to do a couple of things here. I want you to listen to me closely. I'll be doing a lot of things on this particular equation. A lot of things. First, can we work around our oxidation numbers? Go through the laws. Oxidation number of magnesium here is 0. Anything that is a free state, a freestanding element, oxidation number would be what? 0. So oxidation of this is also what? 0. Okay, let's go to zinc chloride. Chlorine is a halogen, right? Group 7. And we said all group 7s have oxidation number of -1. You got to know your periodic table. Oxidation number here. +1, +2, positive or negative. This one is negative. Check. That's where chlorine is. What's the oxidation number? Negative. So if I come back here, check this, my dear learners. This can now be written, okay, oxidation number of this is -1, but multiplied by what? 2. Okay. Plus that should be equal to what? 0. What is zinc? It's positive what? 2. Have zinc. That's why zinc is written as zinc 2 plus. Chlorine is written as what? Cl minus. It's the oxidation numbers. The oxidation number here, +2. Let's break this one down, 0. I want us to deal with MgCl2 on that side, on the right-hand side, in case I lost you here. Oxidation number of chlorine is -1 multiplied by 2. We don't know Mg, but what? 0. Mg minus 2 equals to 0. So this Mg equals to +2. Oh, that is why we write Mg as Mg2 plus. Chlorine is what? -1. So what's the oxidation number here? +2. Let me rewrite all of this for clarity. Mg, we have chloride, we have magnetite, and we have what? Zinc. Oxidation number here, 0. Oxidation number here, +2. Number here, -1. Magnesium, +2. Chlorine, -1. Zinc, 0. If I were to write all these elements out, let's use a table. Mg. Let's see if a table will work for you before and after. And then we'll write what's going on. What's the oxidation number of oxygen before? 0. 4. And this is what? What's the oxidation number on the right-hand side? +. What about zinc? On the left-hand side, +2. Right-hand side, 0. Chlorine, right-hand side, -1. Okay, which one is increasing? Mg. So because there's an increase here, what do we talk about? Increase in oxidation. We're talking about what? Oxidation. What about here? There's a decrease in oxidation what? Number. What is that? Reduction. What's happened here? No change. Known as a spectator ion. Has no change. It is a spectator ion. Please let me know if what I just did here made sense to you. Must be able to calculate oxidation numbers. Then we compare. If it's increasing, oxidation. If it is decreasing, reduction. If there's no change, that is known as a spectator ion. What can we then conclude, my dear learners? Mg is oxidized to Mg2 plus. Zinc 2 plus is reduced. Please take note. The left-hand side, we have Mg. On the right-hand side, I want to rewrite this thing here, especially what I just, let me take this out. I want to rewrite this because I want you to see. Now I want you to understand this, that we look at oxidation numbers. So it is important for us to be able to calculate oxidation numbers. I'm waiting for a response if you're okay. And if you're not okay, you let me know. I'm waiting for a response. Taiba says okay. Angela says okay. Kutle says okay. Batu, are you saying okay? Tina says okay. Patu says okay. Gugu Mpo. Okay. Those of us watching on YouTube Live, I hope you're okay. Just drop me a message saying you're okay on the chat side there. Just I would like to just read from you. Just let me know that you're okay. Like, tell me you're okay. Now, quickly, once we are done with this, I want us to now write the things properly. We are going to write what is oxidized. We are going to write what is reduced. Okay. We are going to write the oxidizing agent. We are going to write the reducing agent. And we are going to, okay, quickly, what are the things we are going to do? Lovely, Oratilwe. Thank you so much. Got you're okay from YouTube Live. All right. Quick things that I want us to write. What is oxidized? What is reduced? Check. Quick things. We're going to write what is oxidized. We are going to write what is reduced. We are going to write our oxidizing agent. We are going to identify the reducing agent. We are going to write what you call oxidation half equations. We are going to write what you call reduction half equation. Please, I'd like you to follow. These are the 7 things that we're going to do. And we are going to write the net ionic equation. 1, 2, 3, 4, 5, 6, 7. We're going to deal with 7 things quickly. 7. Write what is oxidized, what is reduced. So we're going to use that same equation. We're going to use that same equation to write all of this. So please, I want you to follow through with me. What was our equation? Mg plus zinc chloride to give us what? Mg magnesium what? Chloride plus what? Zinc. All right, if we break this down, we have Mg, we have zinc 2 plus, we have Cl minus because of my oxidation numbers, right? Okay. Let me drop this. I want you to see where those numbers are coming from. Oxidation number is 0, plus 2, negative 1, plus 2, -1, and 0. So what is this one? Mg2 plus, Cl minus, and then zinc. See that my oxidation numbers have become the charges. +2, it became zinc 2 plus. It was -1, it became Cl minus. +2 under Mg, it became Mg2 plus. Like that. Now, what can we say? This Mg, which is a solid, is oxidized to Mg2 plus. I have done the first one. What is oxidized? Mg. Can we conclude that therefore Mg is the reducing what? Agent. Please take note. Whatever is oxidized is the reducing. I am done with number 4. Whatever is oxidized is the reducing what? Agent. Okay? Can we go to the zinc part? Guys, my answers are on the left. Zinc plus, which is aqueous because it's an ion, is reduced zinc. Why is it reduced? Because there is a loss or there's a decrease in what? Oxidation number. Therefore, zinc 2 plus is the oxidizing what? Agent. Again, this one is increase. That's why we call it oxidation. And here is a decrease. That's why we call it Take note of what I'm writing. It is Mg and zinc 2. Pick our answers from the left-hand side. Check again. My answers are here on the left-hand side. Mg on the left, zinc 2 plus on the left. Mg is oxidized, zinc 2 plus is reduced based on the oxidation what? Numbers. I am now done with the first 4. Sense? By using what? Oxidation. Let me know if this is okay with you. Identifying what is oxidized and that what is oxidized is the reducing agent. Thank you, Mr. Michel. We identified what is reduced, but please take note. My answers are on the left-hand side of the equation. Zinc is not reduced, guys. It is zinc ions that are reduced. Okay? Please take note. I want to give you a small note here. Can not reduce solid. Only ions, aqueous, can be that. You cannot reduce a solid. Only ions can be reduced. When we talk about reduction, we're going to talk about ions being reduced. Awesome. Now, we want to round this whole lesson up with the next 3 things. Please, I'd love you. I want to do this without the table. Next week, I'll look at the table with you. All right. I want you to enjoy chemistry first. Mg is oxidized. Okay, please watch this. Mg is oxidized to Mg2 plus. What is oxidation? Find oxidation. What is oxidation? defined oxidation. We said oil. Oxidation is the loss of electron. Oxidation is the loss of electron. Now, when we say loss, loss means you are subtracting. If you lose money, what happens with the money you have? It goes down. So check this. Mg minus, we are losing electrons, right? Oh, I wanted to write something here. Oxidation is the loss of electrons. So we are saying Mg, please check this, minus to us Mg. If I write 2 plus there, it means Mg is actually losing how many electrons? 2. Beautiful. But conventionally, we always write plus electrons. We don't write minus. So what am I going to do? I'm going to move that negative 2 plus to the right hand side. I think I should do this on a fresh page. Please, just 1 second. That we can see the continuity of the note. We are now crowning everything we've been doing so far. This is the Mg is oxidized to Mg2 plus. What is oxidation? Oxidation is the loss of what? I'm doing this again so that we remember loss, there's a minus. But conventionally, we don't write negative electrons. We write what? Positive. So therefore, Mg, if I move those 2 electrons to the other side, what would I have? Plus as my oxidation. Half equation. Why is it half? For it to be complete, oxidation and reduction. So for the fact that I am dealing with oxidation alone, it is called half. Please check very well again. Magnesium loses electron minus 2e. Told you when an atom loses an electron, it becomes positively charged. But conventionally, we don't write it as negative. So we move the negative over, it becomes what? Positive. Okay, that one is done. Look at the second one. Zinc 2 plus is what? Reduced zinc. Let's write that statement out. Zinc 2 plus. What is reduction? The gain of, so if it is gain, can I say plus? So what do we have? Zinc 2 plus 2 electrons to give us what? Zinc. Solid, and that is what? Aqueous. This is known as the reduction half what? We are going to learn how to use a table to do all of this, but in grade 11, I don't even want to work with a table. I want you to learn how to do the table. Showing you the table next week. Oxidation is loss, but like the minus, we move the electron. But I want you to remember, when an atom loses electron, it becomes positively charged. So Mg loses 2 electrons and it becomes what? But we don't write the negative there. We move it over to that side, it becomes what? Positive. Zinc 2 plus is reduced. Don't forget all my definitions, please. Definition here, this is plus 2. This is 0. Reduction. Plus 2 to 0. So zinc 2 plus is reduced to what? Now, my net ionic equation. Net ionic what? Equation. The electrons must be balanced. Electrons must be balanced by multiplying with the number of electrons from other equation. And today, from the other equation because of time. And we add, check this. What do I have? I have Mg to give plus 2E. I have zinc 2 plus 2. The first thing I'm going to check, guys, is the number of electrons. Electrons do we have on the first one? We have on the second one, 2. Why? I have 2 electrons. I'm going to do the one without 2 electrons now. I have electrons here. I have 2 electrons here. Oh, so it's balanced. Write what's on the left to the left. Plus zinc. Plus is on the left. It comes there. Right hand side. What do we have on the right hand side on top? Plus. What do we have on the right hand side at the bottom? That's the whole of grade 11. Let's write this down. I want to look at one that is not balanced so we can balance it together. Quickly write this down. I'll do this example for you as well. There's no need to stress. Run through one quick example with you and show you how to balance. That would be the end of the lesson once I do that, and then we'll take it from there next week in exploring more on what we have done. So right now we are working without the table. There's a table that gives you all of this, but I want you to understand it without a table first. Can I move to the next page? Let me see you. Give me thumbs up quickly. Can I move to? I know it's a lot of information, guys. It's holiday, so sit down with this again tomorrow. Is that okay? Sit down with it again tomorrow. Get it. Get the lesson again. Go through again. Make sure this is sorted. You sort this out, grade 12 becomes an easy walk in the park. This concept is done again in grade 12. Now, in grade 12, what we are doing is we are now doing applications. So let's get this sorted. All right, let's look at this one. Consider. Let's consider this reaction. Fe plus Cl2 to give us FeCl3. Please take note. This is not balanced. We have to balance it. But we are not going to balance the way we're balancing in grade 9 and 10, where we're counting. We're going to balance using reduction and oxidation. The first thing we are going to do is to deal with our oxidation numbers. element in free state has oxidation number of 0. So iron here would have oxidation number of what? 0. Chlorine gas will have oxidation number of what? 0. It's a free state element. Now, on the right hand side, what do we have? We have a compound. Let's do it on the side. FeCl3. Chlorine will always have oxidation number of -1. But now there are 3 of them. Fe plus equals to what? 0. Fe minus 3 equals to 0. What is Fe? Positive what? 3. Sweet. So what do we have here? We have Fe3 plus and we have what? Cl minus. Does that make sense to you? We have Fe here. We have Cl2 there. Oxidation number here, positive 3, increasing. Huh? F is increasing, right? Good. So because it's increasing, what can we say? It is oxidation. Let's write notes now. Fe is oxidized to what? Fe is oxidized to what? Fe3 plus. Right. So we have Fe3 plus. These are ions. All in the equation. Why is it oxidized? Because there is an increase in oxidation what? Number. Therefore, Fe is the reducing what? Agent. Remember, we are saying it is oxidized because there is an increase from 0 to positive 3. Which one decreases again? From 0 to -1. What is that? That is a decrease. And what do we call that? Reduction. Okay, check this. Cl2 is reduced. You see, we are moving from what is on the left to what's on the right. Reduced to what? Cl minus. Therefore, Cl2, chlorine gas, is the oxidizing what? Agent. Guys, my answers are on the left hand side. Fe is oxidized, chlorine gas is reduced. Now, let us deal with half reactions. If Fe is oxidized, what is oxidation? Fine. Loss of electrons. But do you notice that we are losing how many electrons? 3. Beautiful. So we have Fe minus what? 3 electrons to give us what? Fe. But conventionally, what did we say? We don't write as what? Negative. So can I move the electrons over? What am I going to have? Fe becomes what? Fe3 plus what? 3 electrons. That is the oxidation half reaction. Oxidation half what? Equation. Cl2, what happens to Cl2? It is reduced. What is reduction? The gain of electrons. What am I going to have? Cl2 will gain what? 2 electrons. But here's the deal. Check. If I write Cl minus, are you aware that it's not balanced? There are 2 chlorine atoms there. So it means I must put a 2 here as well. And what is this? This is what? Reduction, half what? Equation. I hope you are all good. I only have one more thing to do. Oxidation and reduction. So guys, we don't write this one, we write this. You'd see it from the table once we start using the table. But right now I'm working without the table. I want you to understand what oxidation is and understand what reduction is. Right. Are we okay, guys? Half reaction or half equations, half equations. Remember what I said, the combination gives us the word redox. These equations cannot work on their own. All right, let's balance. Let's quickly balance. Ooh, I'm loving this. Let us balance. Okay, I'm taking this out. We are now balancing. All right, we are balancing. Do you notice there's a problem? What is the problem? My electrons are not the same. I have 3 in the first one. I have 2 in the second. What I'm going to do, I am going to come here and multiply this one by 2. Where is the 2 coming from? Here. Switch the numbers. I am going to multiply this one by what? By 3. Beautiful. Guys, please take note. That's a very important point. I multiply the first one by the number of electrons in the second equation. Then I multiply the second equation with the number of electrons in the first equation. If we do that, what are we going to have? Talk to me. Multiply everything by 2. What will it be? Talk to me. Fe times 2. Fe. Why 6? Give us what? 2Fe3 plus. Now, 3 times 2 would give us what? 6 electrons. That's the first one. Can I multiply the second one now? Tell me what I should write. Cl2, chlorine gas. By everything by 3. Plus by everything. Multiply this by 3, multiply this by 3, multiply this by 3. L2, 3Cl2 for now, plus what? Electrons to give us what? L minus. All right. Now, what would you notice? What do you notice now? Do you now notice that my electrons are now 6, 6? On top, 6 at the bottom. I can just simply strike them out. They are now equal. That was the aim. Strike them out. The aim was to have 6 electrons here on the left and 6 electrons on the right. Now, what do? We can conclude. Write what's on the left to the left. What's on the left on top? 2Fe, which is a solid, plus L2, which is a gas, to give us Fe3 plus what? 6L minus. We have now balanced in terms of ions. have balanced in terms of what? Ions. I want us to try, okay, I won't take more than 2 minutes. In grade 10 and grade 9, we're doing this. Check this. Fe plus Cl2 to give us Fe. What would you do in grade 10? Balance. We would count. Fe1, Cl2 there, and there's a 3 here. I'll come here and put a 2. I have to put a 3 in grade 10. Right? 3 times 2 would give us what? 6. I need to have 6 there as well. So what would I do? I'll put a 2 here. That's not now balanced. My iron is now 2 on the right-hand side. I need to put a 2 here. Now it's balanced. Check your equation. Check what you have. Fe. Can you see the 3 coming out? 3. Can you see the 2 there? Now, somebody's saying, but there's no 6. There is 6. What is 2 times 3? 6. Now it's balanced. We are now balanced using what? Ionic method. Redox reaction. Guys, this is where I'm going to stop for the day. Identifying what is oxidized and what is reduced. Oh, thank you, Mr. Michel. These reactions are called half reactions because they cannot occur independently. All right, that's Mr. Michel talking from our YouTube live station. Both oxidation and reduction must occur simultaneously. Hence, we call it redox. Redox means reduction and oxidation. So both of them must occur at the same time. Guys, this is how to balance. Please, you must be able to write what is oxidized, what is reduced, oxidizing agent, reducing agent, oxidation half reaction, reduction half reaction, and the net ionic equation. 7 points. Where are my 7 points? Those 7 points, it's a must. Without even using a table. What is oxidized? What is reduced? And you get that by using oxidation what? Numbers. Oxidizing agents. Whatever is reduced is the oxidizing agent. Whatever is oxidized is the reducing agent. Oxidation half equation, reduction half equation or reaction, in which case maybe oxidation is loss. So we say minus, but we throw the electrons over to the other side, becomes what? Positive. Reduction is gain, that one is plus. When an atom gains an electron, it becomes negative. When an atom loses an electron, it becomes positive. To balance, what do? We check the number of what? Electrons. How do you do it? You switch them. Multiply, you write them out. Keep what's on the left to the left. Keep what's on the right to the right. Guys, I would have loved to give you a few questions to try. Let me see. I want to give you one to try without the table. I want to give you one. This is the table. Don't worry. Don't get confused. That's why I don't even want to work with the table. All right, let's see. Oh, guys, please get me these 12 marks. The picture. I want these 12 marks. It can be done. 12 marks can be done from what we've done today. Oh, sweet Lord, it can be done. These 12 marks can be done. Let me take a picture and send it to you on the group. Please, these 12 marks, it can be done with what we did today. We covered it, I promise you. Define oxidation, boom, done. Formula of the reducing agent, find what is oxidized by using oxidation what? Numbers. Reduction half reaction, we did that today. Consider the redox, determine the oxidation number, we did that calculation. Balance the above equation using ion electron method, that's the balancing. Come on, 12 marks. I'll give you just that one question to play around with. It's on the group right now. Those of you that are on YouTube, you can also do that homework and get it done. Guys, thank you so much for joining in. We have covered quite a lot of work today. You might not know the gravity of the work covered, but I promise you, this 12 marks has been covered today. Everything we did today is actually tested here in this 12. Before you answer, go through the notes again, watch the video again, and then answer the question. The video is available on YouTube Live. All right. If you just go to YouTube and search for the topic today, I'll send the link as well quickly so you can rewatch. And you can also rewatch on the website. But this particular one is available for you on YouTube to rewatch. Watch it and get it done fast, fast, fast. Have a lovely evening, everybody. Let me drop this one here. A lovely evening and catch you in the next redox reactions in lesson. Showing you how to use the table, and we're already done with the whole topic. Good night, everybody. Oh, that's so sweet, Google. You enjoyed the lesson. Thank you so much. Good night, Kutle. Good night, Taiba. Good night, Patu. Oh, so love. All right, my YouTube lovers and followers. Thank you so much, Mr. Michel. Thank you, Petrus. Thank you, Ratilwe. And thank you, others that did not share a message with was watching. Have a lovely evening, everybody. See you. Subscribe, share the video as well. It's available for everyone. See ya.